Hello and welcome to another lesson for A-level physics. Today's learning intention is to understand the different types of waves. Now before we get started, I'd like to see if you can remember what these are from GCSE. We've got transverse waves, longitudinal waves and mechanical waves. Pause the video to write down the definitions and then press play to check your answers. So a transverse wave, you should remember, is a wave that vibrates perpendicularly to the direction of energy transfer. We use the word oscillates more at A level though, because oscillation is a better word than vibration. Longitudinal waves, by a similar virtue, are waves that oscillate parallel to the direction of energy transfer. And then finally, a mechanical wave is a wave that requires a medium to travel through or a substance to travel through. But again, medium is a more scientific word to use than substance. So today's success criteria is to be able to label transverse and longitudinal waves, to be able to explain what is meant by a progressive wave, and to be able to calculate the speed and the period of a wave. So let's go straight into the labelling of a wave. If you want to, you could pause the video and add the labels to this and then check your answer. Or if you're unfamiliar from this or you can't remember from it at GCSE, just continue to watch. So a wave that is drawn in this manner, we will call a transverse wave because we can see that the vibrations are perpendicular to the distance axes that we have there. Now the distance from from the equilibrium line, the centre line, to the peak of a wave, we will call the amplitude. So the distance from the peak of the wave to the equilibrium position is the amplitude. That is the maximum displacement of the wave or a particle within the wave. Now the distance from one peak to the next peak we will call the wavelength. And then we can also label the peak of the wave itself, and then the opposite to the peak down below there is a trough. You should have done all of that before at GCSE. Now similarly, we can draw a transverse wave like so. And again, we can label the amplitude there as being the maximum displacement of the wave. But the wavelength is not what is being shown between these two peaks. Because if you look at the x-axis, rather than have distance going along the bottom, we have time going along the bottom instead. Now, when we've got a graph where time is along the bottom, the distance between two peaks of a wave is actually called the period of a wave. So in other words, the period of a wave is the time between two successive waves. Then finally, we can draw this type of wave here. This is a longitudinal wave, and it's made up of areas of compression where the particles are close together and areas of rarefaction where the particles are far apart. We can represent that using a slinky like what we've got on the diagram here. Now the distance between the centre of two compressions we call the wavelength, and then along the bottom here I have labelled for us some compressions and a rarefaction as well. You need to be familiar with all three of those diagrams. Now, a progressive wave is a wave that transfers energy from one point to another without transferring any material, i.e. the medium the wave travels through has not been permanently displaced. An example of a progressive wave would be a sound wave, because obviously that transfers energy from your lips and your tongue that are vibrating to your eardrums itself. But an individual particle does not move from your lips to the other person's ear. The particles stay roughly where they are. They vibrate about a general position and pass the energy on to successive particles. So the matter itself, the material itself, hasn't been displaced, although the actual energy has been transferred from one point to another. Again, you could model a progressive wave like this lady is doing for us here. She's moving a slinky up and down, and of course each of the individual coils of the slinky stays roughly in the same place. It just oscillates, but the energy is sent all the way along the slinky. Now the period of a wave is the time it takes for one complete wave to pass a fixed point. Now the frequency of a wave, on the other hand, is the number of cycles that we have per second. They are related to each other by this equation that is not on the formula sheet. The frequency of a wave is 1 divided by the period of the wave. Frequency is measured in hertz, which we write down as capital H and lowercase z, and time period, or just period, is measured in seconds. To calculate the speed of a wave, we need to know its frequency and its wavelength, and wave speed is equal to frequency in hertz multiplied by wavelength in meters. That equation is given to you on the formula sheet. Now what we'd like to do is pause the video and make a mind map about electromagnetic waves. This is a topic you would have done quite a lot of at GCSE, so you should have some background knowledge of it. Pause the video now to write down everything that you can remember about electromagnetic waves, and then press play and add anything that you have missed to your mind map. So, in terms of electromagnetic waves, then there are actually 7 electromagnetic waves that we need to know, and they are all transverse waves. So you need to know that all of the electromagnetic waves, all 7 of them, are all transverse waves, which means they oscillate perpendicular to the direction of energy transfer. We also need to know that electromagnetic waves can all travel through a vacuum. In other words, they don't need a medium to travel through. They're able to travel through space, even though there are no particles in space to pass on any vibrations. We also need to know that all electromagnetic waves travel at the same speed in a vacuum, and that speed in a vacuum is 3 times 10 to the power of 8 meters per second. That should look familiar to you because that is actually the speed of light, and of course light is an electromagnetic wave. Now you also need to know the order of the electromagnetic waves in order of decreasing wavelength. So the one with the biggest wavelength is the radio waves, then slightly smaller than that are microwaves, then infrared waves, visible light, UV, X-rays, and then the shortest wavelength are gamma rays. Now you also need to know what these are used for as well, so if you've not added any uses, please do add uses to your mind map. Radio waves are used for television signals. Microwaves are often used for satellite communications. They can also be used for cooking food as well. Infrared is often used for thermal imaging cameras, i.e. night vision and things like that. Visible light is often used in optical fibres. It's obviously also used for us to be able to actually see. The retina at the back of the eyeball detects visible light. Ultraviolet light has got a couple of uses. It can be used for detecting fake money, forged banknotes. It can also be used for sun tanning beds. X-rays have got a number of uses as well. Obviously you're familiar from probably being about 6 years old that X-rays are used to get pictures of your bones, so we can say that they are used for medical imaging, but we also use X-rays for airport security as well, scanning bags, looking for things that shouldn't be in bags, etc. And then finally, gamma rays have a lot of uses as well. They're used for sterilising surgical equipment, and they're used for irradiating fruit as well to kill any pathogens that may be in it and to increase the shelf life and reduce the spoilage of the food. Now I'd like you to have a go at the following exam question to test your understanding of what we've gone over today. So when you see the exam question appear on the screen, pause it, write down your answer, and then obviously press play to check the answer that you've written down. So the first question comes from 2016. Explain what is meant by a progressive wave. 2 marks. So the answer that we should be giving here is just a routine definition. It is a wave that transfers energy from one point to another. That gets us the first mark. The second mark is for saying it does that without transferring any material. Now part B is a continuation of the same question, but unfortunately you're going to need to use some diagrams. So I'll read you the question, but then you might need to go back to look at the diagrams as well once you're writing down your answer. Figure 8 shows the variation with time of the displacement of one point in a progressive wave. So there you can see how the displacement varies with time. And then it also says that figure 9 figure 9 shows the variation of displacement of the same wave with distance. So we have those 2 diagrams here. I'll flick back to figure 8. For 1 mark each, you would need to work out the amplitude of the wave, the wavelength of the wave, the frequency of the wave, and the speed of the wave using this diagram here in figure 8 and this diagram here in figure 9. So there are the questions. Pause the video to answer them. By all means, go back and look at them, and then we'll go over the answers. So for B part 1, the amplitude of the wave comes out as being 0.6 millimeters. Okay, make sure you include a unit as part of your answer, please. B part 2 asked us for the wavelength. Now you need to make sure to work out the wavelength that you are using the graph that has the distance along the bottom and not the time. The wavelength will come out as being 0.08 meters. The frequency of the wave we can't read directly off either of those graphs, but what we can read off is what the time period of the wave is. The time period we would have read off the second graph as being 44 milliseconds. In other words, 44 times 10 to the minus 3 seconds. We know that frequency is 1 divided by the time period, so we would do 1 divided by 0.044 to give us an answer of 22.7 Hertz. And then finally, we wanted to work out the speed of the wave. We don't need to look back at the graphs now. We know that wave speed is frequency multiplied by wavelength, so 22.7 times by 0.08 would give us an answer of 1.8 meters per second. Hopefully you've done well on those exam questions, and I will see you in the next video.